Hey guys, welcome to the laboratory. In today's video, we are looking at states of matter. By the end of the video, you should be able to describe the arrangement of particles in the three states of matter, and use heating and cooling curves to explain what happens when a substance changes state. So, let's go. Before we discuss the states of matter, it makes sense for us to first discuss the particle theory. The particle theory is used to explain why matter can exist in different phases, i.e., as solids, liquids, or gases. Here's what the particle theory states. All matter, be it living or non-living, is made up of tiny particles. These tiny particles within matter are constantly moving. A change in temperature will affect the speed at which these particles move. And finally, there are forces of attraction between the particles that are holding them together. Now we can talk states of matter. All matter can exist in one of three forms, and these of course are solids, liquids, and gases. In a solid, there are very strong forces of attraction between the particles. As a result, the particles in a solid are tightly packed together and arranged into a regular lattice structure. The particles, however, do not store much energy, and so their movement is quite limited. To be precise, the particles in a solid are described as vibrating in fixed positions. In a liquid, the forces of attraction between the particles are weak, and this explains why the particles are more loosely arranged. However, the particles in a liquid are storing quite a bit of energy, and so are able to move around more than those found in a solid. We describe the particles in a liquid as moving randomly and sliding past one another. In a gas, the forces of attraction between the particles are very weak. These weaker forces mean the particles in a gas are far more spread out than those in liquids and solids. As well as having weaker forces, the particles in a gas are storing a lot of energy, and this explains why the particles in a gas are moving fast in random directions and constantly colliding into one another. Substances do not only exist in one state. If the particles in a substance are heated or cooled, the energy stored by the particles is changed. This change in energy allows matter to undergo a state change, which, as the term suggests, is the process of matter changing into another state. For example, when a solid is heated, its particles will gain energy. The increase in energy also increases the movement of the particles, and this continues until the solid reaches its melting point. At the melting point, the energy gained by the particles is used to break the forces of attraction between them. The breakdown of these forces means the particles are now more spaced, as they are in a liquid. The matter has now changed from a solid into a liquid, and this state change is called melting. The same occurs when the particles in a liquid are heated. The particles move faster as they gain energy, and this continues up until the boiling point. At the boiling point, the attractive forces between the particles are broken down even further. Now the particles are even less attracted and are far more spaced, as they are in a gas. This state change is called evaporation. Your liquid is now a gas. State changes are reversible, meaning a substance can return to the state it was originally in. If a gas is cooled, its particles will begin to lose energy to their surroundings. This loss of energy slows the movement of the particles, and as the particles slow, they are able to form new bonds. As the gas cools to its boiling point, bonds continue to form between its particles, pulling them closer together. The gas has now changed into a liquid, and we call this state change condensation. The same happens when a liquid is cooled. Energy from the particles is lost to the surroundings, and as this happens, the particles move slower and slower. Bonds form between the particles as the liquid reaches its freezing point, packing the particles even closer. This is freezing. Your liquid has now changed into a solid. Heating curves can be used to demonstrate the changes that occur when matter is heated. Between points A and B on the graph, the matter is in solid form. As the solid is heated and the particles gain energy, we see the temperature of the solid is increasing. And then, between points B and C, the temperature increase suddenly stops. This horizontal line on the graph is where the state change is taking place. At this point, the energy gained by the solid is no longer used to raise its temperature. Instead, the energy is used to break down the attractive forces between its particles. The same occurs as we continue along the graph. Between points C and D, the substance is now in liquid form and will increase in temperature until it reaches its boiling point, which is labelled between points D and E on the graph. The energy gained by the particles is now being used to break those attractive forces further, allowing evaporation to occur and your liquid to turn into a gas. The purpose of the cooling curve is pretty much the same, only this time we are demonstrating how temperature changes as a substance is cooled. Between points A and B, our substance is a gas. The temperature of the gas is dropping as its particles lose energy to the surroundings, and this continues until the gas reaches its boiling point, which is labelled between points B and C on the graph. At this point, bonds are formed between the particles, and they become more closely arranged. Condensation has occurred. And now, between points C and D, the substance is in liquid form, and the particles continue to lose energy to their surroundings until the liquid reaches its freezing point, which is labelled between points D and E. More bonds are formed here, packing the particles even closer together. The liquid now freezes into a solid. Here's an example of an exam-style question that you may be asked on this topic. Pause the video, read the question, and take your time to answer. Don't be lazy now. I'll be waiting for you on the other end with the mark scheme. As this is a 4-mark question, this indicates to us that the examiner needs 4 good points. The question specifically asks for you to explain changes in movement and arrangement of the particles, and so you'll need to make points on both to get the 4 marks here. The mark scheme for this question has 5 marking points in total. The first marking point is for explaining what is happening between points B and C on the graph. We know this horizontal line to indicate a state change, and so you would have needed to mention that bonds are being broken here, or that the particles are becoming more randomly arranged. From A to B, there is 1 mark for explaining that particles will be in fixed positions, a marking point for explaining arrangement, and a second for saying that they are vibrating more as the temperature increases, a marking point for explaining movement. From C to D, 1 mark is awarded for explaining that the particles are arranged in a way that they can slide past one another, and the second mark is for indicating that the movement of the particles will increase as the temperature increases. So, how did you do? Drop your mark out of 4 in the comments below. Don't be too hard on yourself if you didn't quite achieve 4 marks here. Practice makes perfect. Anyway, that's it for this video, guys. Thank you for joining me in the laboratory. Please leave a like on this video if you found it useful, and don't forget to subscribe to the channel so that you don't miss another one. See you soon!